Welcome to Introduction to Quadratic Functions. Let's get started. So one of the parent functions that we looked at in Unit 2 was the quadratic parent function. So here it is, f of x equals x squared. It's quadratic, it's got that little 2 right there, and it's a parabola. And its origin is at 0, 0. So when it moves, left, right, up, or down, it always moves from the origin. And so for Unit 3, we're going to be taking a much closer look at the quadratic parent function. Now with a quadratic function, you're going to start seeing it in standard form. And standard form for the quadratic function is ax squared plus bx plus c. So a, b, and c are all coefficients, so there'll be numbers there when you start to see your quadratic equations. Y-intercepts, just like the linear function, it's when your graph crosses the y-axis. So in this case, it'll be where your parabola crosses the y-axis. And obviously you can find it on your graph, but it's also found by looking at your equation in standard form, and it's your 0, c. It's your c value. So whatever this number is here, that's your y-intercept. You can see over here on this graph that this is your y-intercept right here. Now with the x-intercept, it's where your parabola crosses the x-axis. There are a lot of ways to find this, and we're going to learn multiple ways. But one thing you need to know for now is that x-intercepts are also referred to as roots, solutions, and zeros. So anytime they ask you for a root, a solution, or zero, they're talking about the x-intercept. That'll become very important as we go on through Unit 3. Now the axis of symmetry, you'll also see it written as AOS, and it refers to the vertical line that's going to cut right through the parabola in the middle. It cuts it into 2 equal halves. So you'll see over here that that's the line that cuts it right in half. So I'm going to write axis of symmetry is the vertical line. It goes through the vertex. So the vertical line through the vertex that cuts the parabola into 2 equal halves. Now you can see this on your graph, but the equation to find the axis of symmetry is x equals negative b over 2a. That should be negative b over 2a. So this b and the a are the coefficients from your standard form. You plug them in here and you'll find the equation of the axis of symmetry. So in this case, you can see that it goes negative 1, negative 2, negative 3. So this axis of symmetry is x equals negative 3. And you always are going to have to write it in equation form. You couldn't just say AOS is negative 3. You have to write it as x equals negative 3 because it refers to a line. Now the vertex, this is going to be the highest or lowest point on your graph. So you can see over here that our vertex is a low point right there. So that's my vertex. And your vertex is written in an ordered pair form. It's just that point. The x comes from whatever your axis of symmetry was. So once you find your axis of symmetry, you have the x part of your vertex. So in this case, we know it's negative 3. Then if you wanted to, you could plug this negative 3 into your quadratic equation, which is in standard form, and find y. You could also look for it on the graph, which in this case, negative 1, 2, 3, 4, be negative 4. Now when they ask you if your graph has a minimum or a maximum point, minimum, you can see here, that's what we have here. It's a minimum point because it's the lowest point on the graph. So if you have a minimum value, then it's the lowest point on your graph. That means your vertex is at the bottom. So a minimum always occurs when your graph opens up like that, just like we have in this example. A maximum would be a highest point on the graph when your vertex is at the highest point, And that occurs when your parabola opens down, like this. So then you'd have a maximum point up there. Now, you can just look at your quadratic equation and know whether or not it's a minimum or maximum, whether it opens up or down, because when your A is positive, it's going to open up, just like this. When your A value is negative, then it's going to open down, just like this over here. Now the domain of a quadratic function, of your parabola, remember if this goes on forever and this goes on forever, they eventually cover all your x values. So always, always, the domain of a quadratic function is negative infinity to positive infinity, or you might see it as all real numbers. But the important thing to remember is this is always, every time, no matter how you move it. With the range, your range you still need to read from bottom to top. And it's going to depend on how the parabola moved, up or down, and whether or not it opens up or down. So in this case right here, if we read from bottom to top, it starts at -4, and it touches it, and it goes all the way to infinity. Now if your parabola happened to open down like this, so that means your A was negative, so it opened down, then when you read from bottom to top, you would start at negative infinity to whatever the highest point on your graph was. Now you're welcome to try the example that's on the back of your note sheet by yourself to see if you got it, but we are going to do it together in class. Don't forget to watch your next video. Thanks for watching. See you soon.